If you look behind me today, we are doing section 11.6, which the actual problems are on page 45 and page 546. It's 8 problems because we're doing the teals. Okay. Now, the first 4 problems don't really involve much work. It's more just reading the problem and figuring out whether or not it is a binomial distribution or not. Okay, and then the last 4 is when we actually have to work them out. All right, so we're on section 11.6, but I want you to not look at the problem page yet. I want you to focus on the very first page of the section, page 540. Okay, page 540. This box right here is what we're using for the first 4 problems. Okay, this box right here is what we're using for the first 4 problems. Because in there it's talking about the binomial experiment properties. So, because on 1 through 4, it says determine whether each experiment is binomial. If it is, then we have to do some other work. So to be able to determine whether or not it's binomial, it has to meet these properties in this box. So that's what we're starting with. First of all, the prefix bi means 2, okay? Binomial has 2 terms. A bicycle has 2 wheels. Bipeds have 2 legs, okay? So a binomial experiment or binomial trial has 2 possible outcomes. So the one that's what you want is called your success, and the one that's not what you want would be your failure. Okay? And then the experiment is how many times they actually do it. So it could be, if you flip a coin, you have how many choices?
2.
You have heads or you have tails, okay? If you're trying to get it to land heads up, that would be considered your success, and landing with tails up would be considered a failure. Okay, so those are your 2 things. If I was doing it 20 times, then that would be my number of trials, my N. It's how many times you actually do the experiment. Okay, so for our binomial experiment properties, first, you have to make sure there's only 2 outcomes, so heads or tails. Or if I have pencils or pens in a bag, I've got 2 outcomes. I'll grab either a pencil or a pen because there's only 2 choices, okay? Second, you need to make sure each trial is independent. If I flip a coin, what it lands on this first time, does that have any impact on what I'm going to get the next time I flip the coin?
No.
No, they're 2 totally separate things. So that means they're independent of each other, okay? Then it's a fixed number of trials. We're only flipping the coin 20 times, or we're only flipping it 10 times, or we're only picking something out of the bag 5 times, whatever it is. It's got a set number of trials. And then the 4th property is the probability of success is constant on every trial. So I have the same chances of getting what I want every single trial, okay? So if I'm flipping a coin, I have a 1/2 chance, 1 out of 2 chance of getting it to land on heads every time I flip the coin. Okay, so my probability is the same. So those are the characteristics from 540 that we're going to be using for 1 through 4. So we're going to read through the situation and then double check and make sure it meets all these criteria. If it meets these criteria, then we will identify the different parts. Okay? So let's look at number 1. It says Brianna throws a ball at a target 15 times. Okay, so 15 would be the number of times she threw it. That's the number of times she did the experiment. She can hit the bullseye 60% of the time. What is the probability that she hits the target 10 of the 15 times? So when she throws the ball, she has 2 options every time, right? She can hit the target or miss the target. That's the 2 options. Okay, so it's binomial. It's got only 2 outcomes. Does me hitting it the first time have any impact on the next time I throw it?
No.
No. So it's independent. So it meets the second criteria. Is there a fixed number of trials? Did it tell you how many times she was doing it?
Yes.
Yeah, it told us a fixed number of trials. And then the last one is the probability of success constant. It said she hits it what percentage? 60%.
60%.
She has a set percentage on there. So it meets all of our criteria. So yes, it's binomial. So for number one, first thing we're going to say binomial. Okay. So that's our first criteria. It's a binomial. All right. Now the next thing it wanted to know what the actual trial was. What is she doing? Oh, I just knocked everything over. What's she actually doing? She's throwing a ball, right?
Yeah, ball.
Okay. Now, in my one book, my teacher edition book, it says she's throwing a ball. In my solution key, it says she's throwing a dart. So apparently somebody didn't agree on when they wrote the problem. So anyway, but that's your probability. She's throwing a ball. And then it also wants to know our N. Our N is our number of trials. N stands for number of trials. And it was how many times she was throwing the ball? 15. Okay. Now, our success would be hitting what?
The target.
Hitting the bullseye, right? Hitting bullseye is the success. Did it give us the probability for that? It said she did it how much?
60%.
60%. So our P and we'll get to the formula here in a minute, but the P that it's asking about is your probability of success. Now it's a percent. Now when we're using it in a problem, do we leave it in its percent form?
No.
Yeah, we always change it to a decimal. So our
Decimal.
P value, our probability of success would be 0.60 because you move the decimal point 2 places over. Okay? So it's 0.60. So if our success is her hitting the bullseye, a failure would be what?
Missing.
Missing the bullseye. Okay, now let's make common sense. When we do probability, remember it adds to equal 1 or 100%. So if she makes it 60% of the time, what percentage is she missing it?
40%.
40%. So our probability of a failure, which since they use P for probability, they just went to the next letter for failure. P is probability of success. Q is going to be your probability of failure. It's going to be 40%. These have to add to equal 1 or 100%. Okay, so that's our answers for number one. I'll scoot a little closer. Everybody can see off the glare. Okay. So when you see my formula up there, that's where we're going to be talking about those numbers later. Okay. So it's binomial because it met all 4 of our criteria on page 540. Okay. We have what she was actually trying to do. We have what the success was, what the failure was, and then we have our N, which goes with our trial. It tells you how many times they were doing it. We have our P, our probability of success, and we have our Q, which is our probability of failure. Okay, so those are what we're looking at on here, and we're going to be using this. You got to make sure you kind of start getting the idea of what these things are, because we have to be able to identify them to actually put them in the formula when we're solving them on the last problems. So let's look at number 2, new situation. We're not talking about Brianna anymore. Now we're talking about Liz and Robert. It says Liz and Robert are competing to see who can ride their bikes around the neighborhood faster. Okay, Robert wins 55% of the time. If they race 10 times, what is the probability that Robert will win 7 of the races? So, first of all, for our binomial, does it have 2 possible outcomes only?
Yes.
Robert could win or Liz can win, right?
Yeah.
Robert can go faster, Liz can go faster. Okay, what's the next thing it's got to meet? Is each one independent? Yeah. They ride around
Yes.
now. Okay, they ride around again tomorrow. Does that have any impact on what they did the next day?
No.
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 Okay, so they're independent. There's a fixed number of trials because it says they did it 10 times. Okay, and is the success constant? Did it give us a set percentage for Robert winning?
Yes. Yes.
So it's binomial. Okay, so it is binomial. Our trial is them racing around the block or whatever it is, right?
Yeah.
Riding in race. Okay, that's your trial. Them riding in the race around the block. Okay. How many times did it say they were going to do that trial?
10 times. 10 times.
10 times. So that's our N is 10. Now, success is going to be considered, it was talking about what's the probability that Robert will win. So success is Robert winning. I'm going to spell Robert wrong. So success is Robert winning. So our probability of him winning was what percentage?
55%.
We got to a decimal, so it's 0.55. Okay, now failure would be not Robert winning, but what?
Liz winning.
Liz winning, or Robert losing, whichever way you want to word it. Okay, and the probability of her winning is, if he wins 55% of the time, she only wins
45.
45% of the time, because remember they have to add to equal 100%. So your probability of failure is 45.45. Okay, so pretty easy. Hopefully, maybe.
Yes.
So on number 3, now we're talking about some other people. We have Dyson and Luke. Dyson and Luke are flipping a coin to see who gets to play first in the board game they are playing. They decide that the winner of the best of 5 times will get to go first. What is the probability that Dyson will go first? So, if I'm doing best of 5, do you think that's going to be a binomial one?
No. No.
Okay, now our first criteria was that it has 2 outcomes. It has 2 outcomes because they're flipping a coin. Okay, there's 2, like one has heads, one has tails. So either Dyson wins or Luke wins. So it fits that criteria. But it doesn't have a set number of trials because when it's best of 5, they could have to do it 3 times. It may take 4 times, whatever. Okay, but there's not a set number of times. So we say not binomial. And it wants to know why. And we say no set number of trials. There was no set number of trials, so we cannot say it's a binomial experiment. Okay. Now, number 4, a student body election with 65 potential student voters is held. When the results are tallied, it is discovered that the winning candidate received 56% of the votes. If 20 voters were selected randomly, what is the probability that 18 would have voted for the winning candidate? Okay, so looking at the picture there, apparently they only have how many candidates? There's 2 candidates.
2.
Okay, so we have 2 possible outcomes. They either vote for the winner or they vote for the other one. Okay. Is there a set number of votes?
Yes.
Yes. Okay. Is there a set percentage of the winning candidate's votes?
Yes.
Yes. Okay, so do we think it's going to meet our criteria to be binomial?
Yes.
Yeah. Okay, so number 4 is binomial. So since it's binomial, we have to identify what the actual trial is, the success, and the failure. Okay, so the actual trial is voting in the election. Okay, because you had vote this candidate, vote this candidate. That's your actual trial. Okay, it said how many voters were they actually going to look at?
20.
20. So they were looking at 20. So that was our N, our number of trials. Okay, so success would be vote for the winning candidate. So the opposite, the failure, would be vote for the other candidate, right?
Yeah.
Yeah, the winning candidate, or you have the one who didn't win. Okay, now, what was the probability of them voting for the winning candidate? What was the percentage they gave us?
18 of 56.
So it's 0.56, because you just changed the percent to a decimal. So the vote for the other candidate, your failure probability, you take this from 100 minus 56 is
44.
44, so it'd be a 44% or 0.44 probability of failure, not voting for the candidate. Okay? So everybody got 1, 2, 3, and 4 down?
Yes, ma'am.
We're good? All right. Now let's roll on over and we'll start talking about where we have to solve them. I know that makes you happy. Make noises. So we're going to start by looking at the formula. Okay, you've got it there in your book too. The probability formula, it's kind of like the binomial theorem that we did like in the last chapter. Hopefully that sounds a little bit familiar. And we did binomial expansion. Okay, and it's kind of similar to that because this is called binomial distribution. All right, so we have the C thing, which is a combination, remember. We have N is our number of trials, which we just learned about those. Okay, X is going to be the number of his successes. So like when Liz and Robert were running around the block, or whatever it was, okay, or riding, they were riding bicycle, I think. When they were riding around the block, okay, it says, what's the chance of Robert winning 7 times? Okay, and they were doing it 10, so this would have been 10, this would be 7. Then our probability is the percentage that we had for our P as a decimal. Okay, the number of successes, I left off my S at the end. Okay, is the same as this. Our Q is our probability of failure, which we already talked about how to find that. You take 1 minus your probability of success. And then this, if I take the number of trials minus the successes, that leaves me with how many failures they're going to have. So that's our formula that we're going to use. Now, the way this works is, first of all, we got to read the situation. We need to identify all this stuff so that when we go to plug it in the formula, we plug stuff into the right spot so we can simplify it. Now, as you can tell from looking at this, are you probably going to want your calculator to try to work these out?
Yep.
Yeah, so if you've got one, make sure you got it handy. Okay, I got to turn my page. All right. Verse 7, it says, determine the probability of each of the following situations. Round each answer to 3 decimal places. So that means 3 places behind the decimal point, which has been pretty standard throughout this whole chapter when we've been doing our probabilities. Okay? So it says, at the start of every football game, a referee flips a coin to determine which team will get the ball first. If a particular referee does this for a total of 12 different games during the high school season, what is the probability of 8 of these flips resulting in heads? Okay, so first of all, how many times is he flipping it total? How many games are there?
12.
12. Now, how many times is it saying he's getting heads? 8, right?
Oh, yeah.
Now, so they're considering heads to be a success, so the failure would be getting tails, right?
Yes.
They're considering heads to be a success, so the failure would be tails. So if I have 12 trials, 12 flips total, 8 of them are heads, how many will be tails? 12 minus 8. 12 minus 8 is just 4, right? Yes, 4. These have to add to the total. If he gets a heads 8 times, then that means the other 4 times he got tails. Now, our probabilities, when you flip a coin, what's your chance of it getting on one side or the other?
50.
50%, right? So both our P and our Q will be
0.5.
You have a 50% chance of it landing on heads and a 50% chance of it landing on tails. Okay? Unless you got a trick coin, which you don't need to do that. Okay? So to find our probability of this now, we go to start plugging into our formula here. And it starts with the combination. Now, remember, if you have the scientific calculator above, mine's above my division key, it has the little NCR that you can just use that to plug it in. But if not, you can plug it in. NCR, remember, and write it right here. NCR is equal to, remember, n factorial over n minus r factorial. No. What am I writing? Over I'm writing that backwards. N factorial over r factorial n minus r factorial. There we go. I was trying to put the one thing on top. Okay. So this is our basic, except for r, instead of r, it's x. Okay. When I think of it, x. All right. So we're going to write this out. So I'm going to have my combination part first, which is 12 choose 8, or 12 factorial over 8 factorial 12 minus 8 factorial. And then I'm going to have my probability P raised to the x power, which was 8, and my probability Q raised to the n minus x power, which was 4. So that's all the stuff that we got to try to multiply together and work out. Okay? Now, if you remember, when we did our probabilities, the factorial stuff, 12 factorial means 12 times 11 times 10 times 9 times 8 times blah, 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 blah. This is 8 factorial, and then 12 minus 8 is 4 factorial. So the 8 will mark out the 8 and everything down from there. So I'd have 12 times 11 times 10 times 9 is the 8 part's going to mark that out. And then on the bottom, I still have 4 times 3 times 2 times 1. And then that still times 0.50 to the 8th power, and 0.50 to the 4th power. So what I tried to do when I got to this point is, I know 4 times 3 is 12, that cancels out. 2 goes into 10, 5, and then you just start multiplying everything together. Now, if you do have the scientific calculator with the NCR button, you can just put that in, okay? But I don't, I'm doing it the long way, so if you don't. 495, and then 0.50 to the 8th power. One over 256, and then 0.50 times the, wait a minute, 4th power, 1/16. Okay, so we got to multiply all those together. Y'all getting them? Yes, no, maybe? What? I keep hitting the wrong button, so that's not good. 1/16 times 1. Y'all get an answer? Yes, no? Anybody get an answer? Some of you are just sitting there like, I ain't working that out. You just tell me what it is. Yeah, that's the look I see on some of you. Uh-huh.
Yes.
Those of you who are smiling, you know I'm talking about you. Yeah.
Yes.
All right. Can you see that? It's a big long decimal, right? We're supposed to round to how many places?
3.
3. So I'm going to end up with
121.
0.121, because the 8's going to make it go up. Okay. See, isn't that fun? No, not really. Okay, but we can do it. It's all right. We'll make it through. All right, let's look at number 8. Number 8 says 26 small tiles, each labeled with a different letter, are placed into a bag and shaken. A volunteer then reaches into the bag and takes out one tile, records the results, and puts the tile back in. This occurs 7 different times. What is the probability that a vowel is drawn 2 times? Do not include Y as a vowel. So our vowels are what letters?
I-O-U.
A, E, I, O, and U. So success is considered getting a vowel, right? Success is considered getting a vowel. So the failure would be getting a consonant. Okay. There were 26 letters in the alphabet. Okay. So it said they were doing the trial how many times? 7 times?
Oh, yeah, 7.
They're doing it 7 times, and she wants to get a vowel twice, right? That was
Yes.
okay.
Yeah.
So she wants a vowel twice. So if they're doing it 7 times and she gets a vowel twice, how many times does she not get a vowel?
5 times.
5 times, no vowel. So getting a vowel is success. Not getting a vowel is a failure. Okay, so you have 7, 2, and 5. Now, there are 26 letters in the alphabet. In case y'all didn't know, it told you 26 small tiles, each with a different letter. There's 26 letters in the alphabet. Now, there are 5 vowels, A, E, I, O, and U. So your chances of getting a vowel are 5 out of
21,
26.
26.
5 out of 26. Your chances of getting not a vowel would be 21 out of 26, correct?
Yep.
Now, we're just going to leave those as fractions right now because it's stupid to try to change them to decimals and then go back and they'll end up in back and forth. So we're going to leave them like that. So we're ready to plug them into our formula. Now, our formula says we do the combination first of 7, picking 2. We have 7 trials with 2 successes. So I have 7 factorial over 2 factorial, 7 minus 2 factorial, or just 5 factorial, right? And I have my probability of success, which was 5 out of 26, to the x power. And I have my probability of my failure, 21 over 26, to the n minus x, or 5th power. So that's our formula. Now, when we go to simplify, what I do is I focus, I focus on the larger one of these in my denominator to try to cancel it out. If I'm not using the scientific calculator with the button, that's how I cancel it out. So I focus on 5 factorial, I cancel everything but the 7 and 6 from this. Because this is 7, 6, 5, 4, 3, 2, 1. And this is taking out 5, 4, 3, 2, 1. So I'm left with 7 and 6 on the top. And then on the bottom, I'd have 2 and 1. So 2 can go into 6 3 times. So that part simplified pretty good to 21. So I have 21 times this 526 squared, and then 21 26 to the 5th power. So use what you got. Hopefully you got one with the fraction button. My little fraction button in here. Oops. Well, 5 over 26. Be careful if you are squaring a fraction that you put the fraction in parentheses when you square it or raise it to a power. Because if you don't, it's only going to do part of the fraction, not the whole thing. Now, when I did this, I got this big old long decimal, okay? So see, it gave me a big old long decimal. I'm going to put blah, 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 da, da, da. I'm going to leave that in my calculator as my answer. And then I'm going to multiply that by the 21 and by the fraction 25 over 676. And so I get a decimal. What are you all getting for your final answer? Anyone other than Micah actually trying to type it in and get an answer? I hear no one.
I'm trying, Miss Twelve. I'm trying.
Okay.
I mean, like, I got it, but like,
See, this one over here looks like she's too busy talking to somebody on the side. Miss Chanelli.
I got it. Hold up.
It's too high, honey. All I see is the white part.
It's 5. I don't know. It's wrong, Miss. I did it wrong.
How do you know you did it wrong?
Because yours looks nothing like mine.
Well, why not?
I don't know, Miss.
All right. I got .267.
Let's go.
I'm assuming that's what he got. Okay. Now, where did you go wrong, Aurelie? Where is it different?
I put it all in the calculator. All together.
See, I tried to do just a little bit at a time and then put it all together. Okay. All right. On 13 and 14, they each have two parts, part A and part B. Okay. We're going to look at setting up part A for 13, and that's where we'll leave off, and then we'll finish up tomorrow and start reviewing tomorrow. Okay. So on number 13, okay, for part A, it says, a student takes a 10-question multiple choice quiz with 4 choices for each question, assuming he guesses on all 10 questions. What is the probability that he will answer 7 of them correctly? So the 2 options are he gets it right, he gets it wrong. Okay, so success, of course, is getting it correct. Failure would be getting it wrong. Okay. Now, there are 10 questions. So our number N is 10. It wants to know the probability in A of him getting 7 correct. So that's 7 successes. Okay. All right. So if he gets 7 correct and there's 10 questions, how many is he missing?
3.
3. So that means 3 would be wrong. Okay. Now, our probability of him getting it right and him getting it wrong. This is where you have to be careful. Remember, it said it was a multiple choice, and each one had how many choices?
4.
4. So the correct choice is 1/4. You have a 1 in 4 chance of picking the correct one. So 1/4 is what as a decimal?
0.25.
So 0.25 is getting the correct answer. So getting the wrong, there's 3 wrong ones out of the 4, or
0.75.
0.75. So those are the numbers that we're using for part A. So when we go to plug it in, if you have the little NCX that you would have 10, choose 7, and then you would have P 0.25 to the 7 and Q 0.75 to the N minus X, which is 3. And then remember this, it would be 10 factorial over 7 factorial, 10 minus 7 factorial. And then you still have the other stuff. For this part of it, remember what I told you this means. This means 10 times 9 times 8, blah, 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 beyond. 10 minus 7 is 3, so I have 7 factorial and 3 factorial. The 7 factorial would cancel the 7, 6, whatever down from there, so it's gone. Here, I'm still left with 3 times 2 times 1. And then you try to simplify. 2 can go into the 8 4 times, 3 can go into the 9 3 times. So this part right here, this first section, is just equal to 120. 10 times 3 times 4. So you'll have that times the 0.25 to the 7th and the 0.75 to the 3rd. Okay, so that's for 13A. When you multiply those out, your success and your failure. Okay, now, Some of you need to remember if I sent back a quiz to you that you need to look back at it and try to send that back to me. I told you some things to look at. Mark Keith, I will grade yours because I had to figure out who they were from first. And then I'll let you know on those. Make sure you finish solving this one. Like I said, tomorrow we will finish this section. And then we'll be reviewing because we will be done with chapter 11. So that means test is coming. Okay? And some of you need to make sure you do well on here because you didn't do so great on the last one. Okay? Of course, some of you, that may be because when I'm going over stuff in class, and I even called you out on it today, and you still just ignored me, and I tried to unmute you, and you have it blocked where I can't do that. But if I'm up here talking, going over a problem, and I see you just looking sideways the whole time, talking to somebody else, you are not paying attention to me. It's 45 minutes of class time. It needs to be undistracted. You need to be here on time, and you need to be ready to work the entire 45 minutes. If I keep seeing it, I'm kicking you out, and then you need to explain to your parents why you're not getting the problems from the lesson because you got kicked out because you were just wasting my time. We have 4 weeks of school left. I expect better and I deserve better. Don't ask me for help if you're not putting forth effort. I'll see you all tomorrow.